Here we are with the 10.4 notes, area of regular polygons and composite figures. When we're looking at a regular polygon, we want to understand that it would be inscribed inside of a circle. The center of this circle would be P, and a segment drawn from the center of a circle to the outside of the circle would be a radius. So we'd have BP and AP, which would each be radii. We have a new word today. It is apothem. Apothem is the name of a segment that goes from the center to the side of a regular polygon at a right angle. It is the perpendicular bisector of that side. Sorry for that. The central angle has a vertex at the center of a polygon, and its sides pass through consecutive vertices. So in this problem, A and B are consecutive vertices, and the sides of this angle pass through those vertices, and they're in the center of the circle. That's why it gets its name, the central angle. We'll learn more about this when we study circles in a short time. The measure of a central angle of a regular polygon is 360 divided by n. It's the same as an exterior angle. So that's actually kind of an interesting fact, is that this angle here, the central angle for both of these parts, is equal to the exterior angle, which is formed by the polygon and a straight line. The polygon and a straight line this way. So this angle right here is the same as this angle right here. All right, let's move on from that. Here's our first problem that has to deal with the formula that the area of a regular polygon is 1/2 times the apothem times the perimeter. You can see I've laid out that formula here. If I know the side length of something is 10, then I know that the half side of that is 5. There's a few different ways I can figure out what this angle is in the apothem triangle, which you should draw as I do as well. You're going to want to start in the center and go straight down, forming a right angle and connecting like so. So if I know this whole part is 10, then I can tell that from here to here is 5. It's the perpendicular bisector. This is going to be the half central angle right here, and this is going to be the half interior angle right here. And those are going to be important for the calculations that we do. We'll continue to work with this, and you'll get the hang of it pretty quick. For the remaining part of this video, I'm just going to show the examples and the correct solutions. If you find a mistake, please let me know. I try not to say things are easy, but this one's easy. You get to abort the mission once you realize that this apothem is half of the full side. It's because you have a 45, 45, 90 triangle coming from the square. Number 4, it seems like a triangle would be easier, but this one's actually difficult. The segment they give you is the radius, and that's the hypotenuse of the apothem triangle. You work to get the 30 and the 60, use special right triangles. I've used the expanded version of perimeter, as sometimes I find it easier. This is the most complex problem that we have today in terms of the algebra and the arithmetic involved. 1/2 apothem perimeter is still our star. We have a hexagon, so half the central angle is 60 degrees. We have the area equals 1/2 times 10 root 15 times 6 times 20 root 5. Again, I've used the expanded version of the perimeter. When we factor out 75 to 25 and 3, 25 can break down as 5 and 5. when you pull out the 5s, they're going to interact with this 600 to make 3,000. So you get 3,000 root 3. Our units are centimeters. We're talking about areas, so we're going to be centimeters squared. When I'm given a shape that's more than the sides I really want to draw, I just draw it as if it's maybe a pentagon or hexagon and understand that this is an approximation for what we have. Again, I'll continue to work with you on how to get these interior and exterior angles. Let's talk about this one. The exterior angle is 360 divided by 10, because n equals 10, because it's 36. The interior angle, therefore, is the supplement of that, 144. And half of the interior angle is 72 degrees. So half of the interior angle is what we use in getting the 72 in this place. We're looking to find the Apothems, so we set up a tangent of 72 is a over 2, and that means that 2 times the tangent of 72 is a. And the last example we have here is that to find the area of an octagon with a radius of 12. Again, when we're given a radius, we're going to have a lot of work to do. I'm probably going to walk you through this in person. One of the patterns you're going to make sure that you know very well comes at the bottom of this page, that if n equals 3, n equals 4, just wait 1 second. I'm like 30 seconds away.
It's good.
No, you chill. Chill. If n equals 30, the half interior is 30 degrees. If n equals 4, the half interior is 45 degrees. If n equals 5, the half interior is 54 degrees. And if n equals 6, then the half interior
is 60 degrees.
Nice job. What you'll notice is you'll kind of just need to know those numbers as familiar. 30 should already be familiar to you, but it corresponds 3 to 3, 4 to 4, 5 to 5. It matches the tens place for the most common shapes that we investigate, and so that can be a helpful pattern just in terms of knocking some of these out and developing some rhythm and some efficiency. Thanks a lot for watching. Good luck.